that in a second. Cool. All right, so enough talk, enough theoretical stuff. Let's see some code, especially for those of us who have never seen any REST. So, hello world, classic example. It probably looks pretty familiar. This is very similar to like C-like syntax, right? Or JavaScript or Java, whatever you want. A couple things to note. You'll notice that let's see if I can, oh darn, my mouse has to go over here and then it's all super slow. So you'll notice that we use the fn keyword for function. It's fine. And you also notice that println has an exclamation point. That actually is meaningful. That means that it is a macro. And when you think macros, please do not think C, C++ macros. It is not the same thing. It's way better. You don't have to be afraid of them. But they are different than functions, so we use the exclamation point to make it very obvious that they're different without being quite as extreme as like the screaming uppercase underscores as C and C++ do. So anyways, great. Let's do some more things. OK, so writing your own functions. Here's a really stupid function that doesn't do anything meaningful, and you wouldn't write it this way, but I just wanted to demonstrate. Have a combined function. So you'll notice that the names come before the types, which is different than most other languages. I think it's kind of nice. You can like it or hate it, your choice. I think it's cool. You'll notice that the let keyword, I'm gonna get my mouse over here again. You create variables using the let keyword. That'll be familiar if you do like JavaScript or other things. I think maybe C# has this too, or maybe with var. I don't remember if they have let. Anyways,
C# is var.
It's var, yeah. OK, so use the let keyword, and you'll notice this is the implicit typing I mentioned. You don't have to say it's a U32. It just knows, like, well, X is U32, and you've added 1, and that means X2 is also a U32. Great, I don't have to tell you. You can figure it. Compiler's smart enough. He can figure it out. If I do something wrong, if I try to like add it to a string, he'll yell at me, except in a very, very nice way. He's very loving, but he will let you know you're doing something wrong. You'll also notice that there's no return keyword. It's a similar way to Ruby or Haskell or probably a million others. You can have implicit return. Last expression of a statement is the return. But you can use a return keyword if you want to exit early, which is very useful in some situations.
But the function itself does need to be explicitly typed.
Yes, yeah. So as opposed to things like Haskell, where everything can be implicitly typed, functions do have to be explicitly typed, which honestly, in every language that has like all implicit typing, usually the best practice is annotate your methods or your functions with types anyways. So this one just kind of makes it necessary instead of just best practice. So yeah, and that little arrow there is the return type of the function. So it takes two U32s and produces a U32. What is a U32? It is an unsigned 32-bit number. And a signed 32-bit number is I32, which I like a whole lot better than like the word unsigned int. Just way too long for me. So U32 is great. And what if you want an 8-bit number? Well, it's U8. What if you want a 16-bit number? It's U16. OK, great. Very simple. Yeah, I think we did all that. Yeah, great. Yeah, cool. OK, so what about like, we want our own data types. We don't want to just use primitives all day long. So we can use structs. If you know C and C++ structs, they are very, very similar. In fact, you can make them pretty much the same. Yeah, pretty basic stuff. You can see it. The one thing you might notice is kind of weird is you declare the shape of your data in one place with the struct keyword. Oh my goodness. Let's get that out of the way. OK, so you declare the shape of your data in one place. And then you describe the behavior in a different place. There are actually legitimate reasons for this, and they'll come into play much later. I'm not going to talk about it, but there are good reasons for it. And I personally like it, because the thing I don't like is when I go to like a humongous 10,000 line long Java class, and there's like a bunch of like members, and it's kind of hard to tell where the members begin, where the members end, and the functions begin. And you can even throw a member in randomly later, and you would never know, and you never see it. So, anyways, I think it's great. A couple things to create a struct. You just use so create a variable, and then you just kind of like say the name of it and do it in curly braces with your numbers. If you want to create your own constructors, you can do that too. That's usually what I do, but this is how you create it at the end of the day, like in the constructor. And one kind of nice thing too if you've ever written a million two-string functions in Java, you can now derive debug, and it'll just give you a debugging version of two-string for you for free, which I think is great, because I don't like repeating myself. So
Now, when you derive debug, does that build that only builds when you're doing a debug build, and it's left out of
no,
when you're doing a production build?
that's different. So there is a concept. So I wasn't going to talk about this quite yet, but it's fine.
Take you off track.
Oh, you're fine. You're fine. There is a concept of like debug builds versus release builds, and I just the other day. So so story time. If imagine you're writing Rust and you're like, man, Rust is supposed to be fast, and this is kind of slow. Like it's kind of fast, but it's not that fast. You got to compile it with the release flag, and then it'll be like a million times faster. I was doing, I don't know if you've ever done Project Euler. It's this like math website with a bunch of math problems. I was doing one of them, and I did it, and I ran it, and I was sitting there for like tens of seconds. I'm like, what is this? Rust is supposed to be fast. And I timed it. It took like a little over a minute. Like, what is this? I was like, oh wait. So I compiled it with release build, and it finished in like 30 milliseconds. I'm like, what happened here? Like, how did we get from 60 seconds to 30 milliseconds, or maybe 300 milliseconds? Anyways.
I've had the same experience.
Oh yeah, it's crazy.
But with practical things, not project Euler.
Oh, you're cooler than me.
Why did I write this in Rust?
Yeah, so that's your little story for the day. And whenever you go home and you write your first Rust program, it'll probably be fine. And then you write your 10th one, and then it's slow, then you can compile with the release. So, anyways, so this debug actually means something different. I'm not going to go into it, but it basically just means like I give you a free two-string for free. So that's great. Talk about that. Oh yeah, and the type inference is still really great. Like let point equal point. I don't have to, and I could call it something else. You don't have to say let point equal point, right? So that's great. You can tell what I like about programming languages. Enumerations. Okay, so this is one of my favorite things about Rust, because I think enumerations are something that come up all the time, and in every language I use that doesn't give me like first class support for these, I just miss it so much. So right here we got directions, right? North, south, east, west. Great. Couple things to note here. So for one, we're going to create one direction : east. Pretty standard, very similar to Java, C++, whatever. So then we have a match expression, and the match expressions are amazing. I'm not going to tell you all the stuff about it because there's way too much to get into, but they're super, super cool. And the one thing is, you'll notice that I don't have a default case here. If I was writing Java, this was 3 hours ago when I was writing Java, I would have a switch statement, I would go over my enums, and then at the very end, I would write default, because because if I randomly added another thing to my enum, my old code would still compile, even if I only had the first 4, right? And alternatively, if this was a return statement in my Java class, or my Java function, and I didn't put a default, the compiler would yell at me and say, hey, you didn't have a default. You might have gotten to the end of this function. And I would look at the compiler and say, you're crazy. I covered all the bases. There's only 4 things. There's only 4 cardinal directions, and I covered them all. And the Java compiler would say, too bad. You need a default case. That just stinks. So the Rust compiler is smart enough. You can either have early exits or like a print line there somewhere. But this one, you're actually all essentially returning a value. This is like that implicit return. And it will check. It knows that I've covered all the bases, and so my code compiles. If I did not cover all my cases, if I left out west, the Rust compiler would look at me and say, hey, just to let you know, you missed something. You didn't cover west. And then my code would not compile until I added west or I added some kind of default case. So that's great. Another thing you'll notice is this kind of looks weird. I don't know. Maybe some of you guys are a lot more experienced than I was. I thought this was weird when I first looked into it. I'm taking a match expression and I'm assigning it to a variable. That's what this is. It's saying take the result of this match expression and put it inside this variable. Once again, this is great. Sorry, I'm going to talk a lot of Java just because that's what my day job is, so I live it all day long.
It's a good reference because it's what a lot of people learn in school.
Yeah, so hopefully a lot of you guys, almost everyone here would probably at least touch Java, so hopefully this makes sense. So if I was doing this in Java, I would have to, somewhere up above, declare my variable, maybe don't even initialize it, and then I would go in my switch statement and then assign it every single time, but that would be very redundant because I say, turn equals forward, turn equals backward, turn equals right, turn equals left. And then I would just have a turn variable afterwards that I could use. Here, I don't have to do all that like shenanigans. I just take the result of this match statement and put it into the variable. That I think is great. There's a million other things you can do with match statements. Not a million. Several different other things you can do with match statements. They're really great. You should love them and keep them close to heart. Yeah. And as a side note, we get rid of null with options because you can actually put more data. You don't have to just say like these 4 things. You don't say, here are the list of things, and some of them have data associated with them. And just as a little like hint, that's how we get rid of null, and it's great because null is worst.
Show that on. What are you talking about?
Oh, that was just a preview. I wasn't showing it yet. Sorry.